Welcome back guys. In this video tutorial I am gonna show you the setup of a sensor that is TMD26721. In this previous videos we have seen working of different digital sensors. For this video I will be showing the working of proximity TMD26721 sensor. It's a member of TMD2672 family which provides complete proximity detection, system and digital interface logic in a single 8-pin surface mount module. Now let's move on to our website, that is controleverything.com, and here searching for this sensor, that is TMD26721, and let's see what we got. So it's an infrared digital proximity detector I2C mini module, and these are some of its features. As you can see, you can purchase this sensor from here, as you can see, and add to cart. Furthermore, I will be showing the interfacing of this sensor with an Arduino Nano, and for that I require Arduino Code. So go to resource tab, and here's the Arduino Code sample you are looking for it. You can download the code as a zip file from here. You can also have the code from our GitHub repository, that is Control Everything Community. So now you have choices from two sources from which you can get the code. You can download the code from both the sources as you wish. Now we need to set up our sensor, and for that we require some hardware. And for that, let's move ahead with the accessories. This is our sensor, that is TMD26721, a proximity detector, which we are going to be setting up. Now we need an Arduino Nano, which you are able to see on my screen. Now the solution to provide the connection among the sensor and an Arduino Nano, and to make it further a lot easier, we require an I2C shield, which is available on our website controleverything.com, and you can purchase it from there. Now this is a connecting cable. Make this connection of the cable and the sensor like this, and while making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same fundamental goes for the I2C shield. Now we need to power up our Arduino Nano. So we need a mini USB cable just like this. Now gently insert it in the power jack. Now we are done with our connections part. Now power up our Arduino Nano by connecting it to the power source, and it will light up. Now let's proceed further. So now we have set up the hardware required for the interfacing. The next thing you are going to want to do is to interface the sensor with Arduino Nano. So for that we have to visit the website and log in to github.com, and here search in for Control Everything Community, which is the official repository of controleverything.com. Type in for the sensor we are interfacing, TMD26721, and here it goes. And this is the required Arduino code we are looking for it. Before going inside the code, let's have a look over the instruction to have a closer watch. We have to download and install the Arduino software ID on our local machine, and this link. Go to this link, this arduino.cc. This is the official Arduino link from where we have to download and install the Arduino. As you can see, it works for Windows, Mac, Linux operating systems. So you can have a lot of instructions, steps and dependencies, and you can have a lot more. To get back, and this is our Arduino code we are looking forward. It's a .ino extension file, as you can see. The first thing you notice is that we have included wire.h library in the code, and we have defined the address of the sensor, that is 0x39. Now first of all, in the void setup function we have initialized I2C communication as master and initialized serial communication with the baud rate equal to 9600. Coming to the writing section, we have set up the device which will work ahead. So for that we have enabled the register having address 0x00 or with 0x80. That is the command register. The command send is for power on, proximity and wait enabled, which constitutes for 0x0D, and in the later part we have selected the proximity time control register having address 0x02 or with command register 0x80, and the command send is here for time is equal to 2.73 millisecond, and it goes for 0xFF. Writing command is here. In the proximity time register, that is 0x0F, we have written this with, or with command register 0x80, and the proximity uses channel 0 diode. The writing part is 0x20. Now here is the delay function, as you can see, and it will give a little time to enable the device. Now in the coming section we have void loop function, and here comes the reading section. We have selected the data register, as you can see, and it is 0x18, or with command register that is 0x80. Here we have requested and read 2 bytes of data. We are getting a new reading here. It pulls a new data which we can process it and see our values. And this is the conversion part, which is being converted into the proximity data for 16-bit value. Now at the end we have formatted, and the data is being outputted on the serial monitor in the form of proximity of the device. And this is a delay function to have a steady value onto the monitor. So this is how the code looks like. Now we can have a code we can call through and have our values. It's a very simple program. Let's proceed further. Now let's give this code a road, see what happens. First of all, copy this entire code and open up the Arduino terminal and paste this entire code and save it and name it TMD26721 for the reference part, and now verify and compile the code. Now it's been compiling and it's done. Now upload the code. As you can see, it's being uploaded and it might take a while. It's done uploading, and now open up the serial monitor for the results. Interesting, the proximity of the device is almost stable, as you can see. Now when I place some object over it, the proximity of the device is being reduced, as you can see, and it's reducing continuously. Now instead of that, if I provide a light source and shed some light over the sensor, as you can see, the proximity of the device increases. So this will have an infrared detector, as you can see. Infrared has a larger impact and it will increase the proximity of the device. So this is how the code works. Now let's proceed further. So we have just seen the working of TMD26721 infrared digital proximity detector I2C mini module. The benefits and the features of this sensor are digital proximity detector, LED driver, and our IR LED in a single optical module, along with register set and pin compatible with the entire series. It has a reduced proximity count variation, saturation indicator, has a high dynamic range like 16,000:1. It has a maskable proximity interrupt, had a good power management. It has a I2C fast mode compatible interface, and it is used being in a lot of applications like mobile handset, touch screen control and automatic speakerphone enable, mechanical switch replacement, paper alignment, and the end products and the market segments include mobile handsets, white goods, toys, digital signage, printing. This sensor is available on our website controleverything.com, as you can see, and go to the resource tab for the required code. You can also have the code from our GitHub repository, that is Control Everything Community. So it's a simple infrared proximity detector sensor, and that is an easy way to get it set up. So I just thought that I would make it clear in case you are in a kind of thought that you are left without fully understanding. If you have any queries regarding this, you can contact us on controleverything.com and post your comments on the community page. You can have a look over the instructions, the articles, and a lot more on our instructables.com page. If you want to subscribe more video tutorials like this, you can go to our YouTube channel. So I hope you enjoyed this and you have a good one for yourself. Thanks a lot for watching.